This is Palomar Estates West noise assessment conducted in April of 2025 and was produced by RB Power Design. The purpose of the noise assessment is to document increased airplane activities over our community as Palomar Estates West, which is located in San Marcos, California. And that's North County, San Diego. I'm trying to look at what the impacts are. Measuring the noise, identifying the planes, helps to kind of quantify if there is an issue or not. Everybody assumes that there's just a complaint, people just complain about stuff, but we really want to find the facts, so that's kind of what we're looking for here. Are there more planes flying over Palomar Estates West? I believe so I say yes. In 2018, the FAA started a program called Next Gen. Here in Southern California, I think it's called Metroplex. But they altered a lot of the aircraft routes and landing procedures. I don't know how much it affected Palomar Airport. Definitely inbound planes are following different routes, so it may have had some effect on it. 2020 was the COVID crisis, so that caused a surge in private aviation. So we feel that there's a lot more privately owned jets flying into Palomar. And then 2023, JSX Airlines moved to Carlsbad. Now they operate the Embaro E135 and E145 jets. And then recently, 2025, American Airlines started 2 daily flights with their regional jet. That's an Embaro E175, so it's the largest of all the jets in the fleet. This is a noise report that you can find on the Palomar Airport website. So anybody can go and look at this. This happens to be the noise report for the monitor that's located in our neighborhood, and it's called Tanakis Drive. I think it's been there a long time because the monitor looks like it's probably 20 years old. So it's probably at least 2 decades, maybe even longer, that's been in place. And I'm not really quite sure what they use it for. I mean, they don't really mention anything about comparisons or anything year over year or anything like that. So, it's hard to tell exactly what this is being used for. So this is a blow-up of that monitor report. And you can see here that from March 2024, we had 52 landings. That was peak. That was the peak level. In March 2025, we now have 61 as the peak day. So there's 2 of them at 61, and I believe probably 2 at 52 in the previous years. Also the daily average, so now we're up to 45 per day. And these are just events that the monitor system is logging. So this probably doesn't include small aircraft that are below a certain threshold. Anyway, so 45, that's a 36% year-over-year increase from this time last year. Something that's interesting here is it says flights that exceed the 70 dB noise limit each day, there was 38. So that was 38 on average. That represented 84% of the flights are above the 70 dB noise limit. And I believe that has to do with interrupting your conversation. So if you're having a conversation, you might be 60 or 65 dB, and then when a plane comes over and it's above 70, it's going to interrupt that. To see the report, you can go online. Palomar Airport, if you Google that, look for the dashboard. You can find the reports there, or you can go to that website that's shown on there, the link. And that's one place that you can find the reports. Now this was a traffic pattern map that was produced in 2005, so this is for our area. And it was part of a Part 150 noise study. So those are Part 150 noise studies, just a pretty common term for studying the impact of the airplanes on at the airport. So they show here the routes at the time, and if you see I've highlighted Palomar Estates West. We had one route that came over us, and it was probably most of the planes, but anything that came in from the coast was routed west of us. So here's the latest one. So this is in the B Pier Annex D 2021. So this is a file that's on the airport website. You can locate that there. It's page or figure 7. And so what I'm showing here again is Palomar Estates West. That's the location, but now instead of one route, they now have 26 routes. And I think some of this has to do with navigation, the improved navigation and stuff. So we're probably getting more planes flying over. Recommended general operating guidelines. So this is found on the back of the voluntary noise abatement procedures handout. And so I circled a few things that impact us. The one that's the top says jets fly the ILS final. So in order to fly an ILS final, this jet has to fly all the way out to Escondido. So there's a waypoint that's right by the I-15 freeway. And they fly to that waypoint, and then they start their descent. So that's I think they call it an initial fix for the airport runway descent. So they're on approach, they're doing their descent, and they're going to fly this ILS. So that ensures that they stay at a certain level. They can't come down a little bit more if they're on a better instrument landing system. So there's a couple different charts that'll show even lower levels. And then the second thing that's circled in there is mainly for the sightseeing over populated areas, and for some reason it's covered up with a picture. I don't know if anybody is ever going to read that, but that just happens to be something that's on there. And then fly the final approach at or above the Pape lights. So those are the lights that you would see. Glide slope when available, or when able. Okay, so you can fly the glide slope when you're able. And I believe that one, again, takes you out to the I-15. They can go out as far as that. I imagine that they could probably maybe intercept it closer to the airport, but just about anything's going to put it right over our heads. So anything west of us is perfect for that. So maybe that could apply to that if it was west of our where the residential community's at. And then at the bottom, transient parking is limited to small single and twin-engine aircraft with wingspans under 38 feet. So that's basically what the airport's actually built for, is Category A and B airplanes, Class 2, I believe. And that would be your wingspan. So they're saying that, if you're stopping there, you can only stop if you've got a wingspan under 38 feet. So I guess if you're taking a trip to Legoland for the day and you want to park your plane, it's got to be a small one. Or, another thing too is they're considering lengthening the runway. And one of the arguments in favor of lengthening the runway is they'll be able to service more airplanes that need fuel. So a plane could land at Palomar Airport and fuel up and then take off. It's a little hard to do right now because the runway's short and they can't necessarily take off with fully weighted, the fuel and all that. This is a Google Earth map, image that I created, and I'm just showing the flight path. That's in yellow. So if you can see that yellow line, it's kind of thin, but that represents the flight path that cuts through there. That's the ILS flight path. And so this is, if you were on a localizer, you'd be flying right along that line. And then if you're on the glide slope, you would enter our neighborhood at about 1,011 feet. That's when they enter the residential area here. And then as they descend, the plane descends at 3.2 degrees on the glide slope. Right about the middle, it's going to cross Rancho Valecitos at about 750 feet above ground level. And then as it exits from the homes west of Linda Vista Drive, the aircraft height is about 690 feet above ground level. So this is really hard to determine because the navigational systems use a barometric pressure. Overlay the photograph of the plane to determine the height. And I try to center my camera lens exactly with that, and then when the plane goes through, I'll scale it for distance to see, because sometimes it's not exactly on path. can be off a little bit one way or the other. And so then we can try to eyeball what the distance is, and then I'll compare that to the flight navigation system. What I've noticed on the flight navigation system is the barometric pressure changes. When it changes, then the altitude of the planes actually are registering lower. So I don't know if they're actually flying lower, but the signal that they're sending out is going to be at a lower level. Well, these are the instruments that I used, and I was using A-weighted, so I wanted to get a measurement on the A-weighted side, and then also C-weighted, so I was using my cell phone for the C-weighting. I wasn't able to calibrate the cell phone, so at the time I did this, it was kind of windy, so I intend to redo the assessment and then try to be a little bit more accurate without any wind, so I have to do it when the conditions are most favorable. And then this is a spectrum plot. So what I do is I record the audio, and then I bring that audio file into a program on my computer. So I plot out the spectrum, and then we can kind of compare that to other planes. So it's good to have some wind influences there. So I really want to get clean audio. So I want to get audio that doesn't have wind. You can see A-weighted. The curve for the A-weighting cuts off some of the decibels in the different frequencies at the lower frequency. I believe it's cutting off about 20 hertz. So 20 hertz is typically what you would hear as a human ear can hear pretty clearly. And then we go down pretty low. I mean, you could probably hear all the way down to 0, but the deeper frequencies are more felt than heard. So the C weighting, it captures most of that lower frequency. You can see the C curve is almost the same as the A on the right side, but on the left side it's a little bit higher. So that's why you'll see the C levels will be higher. This is my spreadsheet that I created. So I like to use Excel spreadsheets when I'm doing something like this. So I'll have a spreadsheet, I'll enter the data, and then I convert that into a table. And then with a table, you can sort each one of these columns, and it increases the usability of the data. So I'll sort it, I add some coloring to it to highlight where you're at. So in this circumstance, I've highlighted over on the right-hand side. If we look at the data, we can see that all the E175s are at the top. So that's a pretty large plane. So that was actually the loudest out of the group. You can see right to the right, I adjusted for distance. And I'll keep fine-tuning this, and I'm going to keep going till I get it where I really feel comfortable with the accuracy. But I adjusted for distance and then compare the distance level to what I'm actually measuring out in the field, because I'm at different locations when I'm measuring, so I have to have a means to say, okay, is this correct? Is this not correct? And what I did for this one was I took anything within about 5% plus or minus of what the expected level was. And I figured that would be a good measurement for accuracy. Because it's going to change, the sound will change. Even just a few hundred feet away from where the original sound was, the engine could be going up or something. So there are variables. So if we see that those are really close, then we'll use them. But if it's below, say, 95%, then I'm going to toss those out of the equation. But for this spreadsheet, these are all the measurements that I took. You can see over here I've got the locations. I've put the date in there, the time. I went back and checked on what the wind conditions were. And I was trying to see if that correlated with louder sound measurements, and not particularly. And then also here I put in if it was below or above the glide slope. Some were right on it, as I checked them. So I put that in there, and then I also identified the category of the plane. And I'm going to add onto that the class too, so we can kind of get an idea of what the wingspan is of each of these planes. So category is just the speed in which it approaches the runways. And then here is my iPhone app. So I'm using it's kind of like a app for people that work in industry. So I'm using that to capture the C weighting. And I might get a microphone for my iPhone if I can calibrate it. Then I'll use this for the A weighting and then use the other meter for the C weighting. And then we can really get some accurate comparisons then at that point. As far as the instruments that I use, so I borrowed a handheld test meter from my neighbors, and he uses this to fine-tune his audio equipment. So I'm trying to measure a different type of sound. This is going to be from airplanes in the air, and it's out in the field, and so there's a little bit of different things going on there. And then I use my iPhone, so I got my iPhone Pro in there with the NIOSH app, and that's pretty well recognized as probably one of the best noise apps you can have on your phone. I mean, it's put together by a college. I think it was Stanford or something. Actually wrote the program, and then you can get it for free and download it on your own phone if you want. And then I've got a Zoom H1 Essential sound recorder, so it's high fidelity, and it records in 32-bit, which is gives you a lot of information about the sound or the noise in our situation. Also, a Sony digital camera. Now that I use for field work when I used to go out and do site visits and stuff, and I needed a capture to document the existing conditions. I would use that camera. So I'm repurposing something I already am using. And then, of course, the WebTrack online airport noise monitoring system. And I use that for cross-referencing data. So I want to try to get away from actually using it as the primary source. And then once I know my data is pretty accurate, I'm just going to use that just to check what I have, and then we'll base everything on the handheld data out in the field. So on the next one, that's what I plan on doing. But for this, I looked at each one of the flights on the WebTrack, and then I cross-referenced that. And then on the next one, I think I'll just maybe just do spot checks. And then if it looks accurate, I'll just go off of that. Here's a slide for documentation. The meter on the right has a built-in tone generator, and you can just check the calibration for. So I ran a calibration check, and it was 94, and that's what the tone generator generates. And you want to be plus or minus 0.1 dB on the calibration. Another thing that I do for documentation is identify the airplane. So when the plane's coming in, I'm using a flight radar app to identify the plane, where it's at, its location. Then the flight radar will give you real-time measurements of where that aircraft is flying. So it comes in really handy for this type of assessment. It's because we need to know which plane it is, and instead of writing that down each time, I can quickly identify it. And it also gives you the barometric readings. They track that. So you can go in, and what I'll do here is I'll capture the data when it reaches about the I-15. So that's their initial fix point. So once it's at the I-15, I can see it's at 3,000 feet or around that. I know it's going to be landing. What I'll do next is I'll switch over to my apps, turn on the meter, turn on the iPhone app. Actually, what I'll do is I'll wait until I get sound. So if I hear the sound all of a sudden, then I'll flip on the camera and the iPhone and start recording. And then what I do is I'll let the plane go by, and then after it passes, once I don't hear the sound anymore, I'll turn everything off. And then we record the audio, so I kind of explained that a little bit earlier. I record the audio to create a signature of what it looks like. And then I create a file folder for each one of the events. So what I'll do on the file folder is I'll name it. I'll put the time and date in it, and then I group these all together by date, and then the location. So I'll have a folder for each location, and then depending on how many planes I've recorded, I mean, sometimes it could be 10 in an hour or more. I mean, I've had quite a few of them sometimes. I'll build a folder for each one of those, and then I load the folder with everything that's in it. So historical record, I keep it in a folder. Not a whole lot of use for any of this stuff really, but I can at least have something for later on. If somebody asks you a question, you can go back and look at it. And I have a pretty good process, so I can flow through this pretty quickly. I'll probably build a folder in 15 minutes or so and collect all the data that's necessary outside of what I've already captured out in the field. Here's the cross-reference with the WebTrack. And again, I'm just using this to test my readings to see how close I am. And I'll probably stop using it, but it's handy for weather data. they do have a pretty good weather data system here, and you can get the dB level and pretty much close to where it's just coming over the sensor. But I just look for the highest level that records. So I'm just taking the highest level here and capturing that. But this, in order to use this, you got to wait like a half an hour. So as far as the availability of it in real time, it doesn't really help much. So that's one of the setbacks from that. See, the other way that I could probably do it is just record the plane going over and then go back and look at this and see what the loudest level was. And that'd be another way, but I think the handheld system is much better. Plus it gives us a more diverse look at what the sound looks like in different areas. And then here's some measurement parameters that I've done. So on this one I took 51 measurements. I did 10 category A. This was 15 category B, 26 C, category C aircraft. And then for the sound pressure levels, I recorded those over 7 days. So what I would do is I'd target an incoming plane that I knew about the approximate time that it was going to arrive. And then I just go up and set up my equipment and wait for it to come. And and while I'm waiting, I could have 4 or 5 planes before and 4 or 5 planes after that would come. So I'd get those at the same time. So in a way, this is a pretty good mix. I didn't focus too much on the smaller planes because those don't really make a lot of noise. So I think I'm going to try to do it as a better representation of what the actual mixture of the planes are, so we can kind of identify the A, B's, and C's. And then measurement by location and distance from the source. So I had 4 different locations where I was taking measurements here in our neighborhood. And so for measurement 1, that's the closest to the web track meter. And that one registered about 75 to 76 dB. That was for 2 measurements. And then 76 was the average. And then we had 6 in camera 4 location. 74 was the average there. And camera 4 is actually a little closer than camera 6. So there was a change between there. It could be that just with more measurements, I was getting a better, capturing more data. Camera 7's a little farther away, so that one was averaging 68. And the camera 3 is the farthest, and that was measuring 59. And then, of course, for the sea level measurements, for some reason they were averaged out of about 10 dB higher than the rest. And if you can see here, 82, 81, 80, and 77, just about the same as the ones up above for distance. Results by category. So this one was pretty good. So we have the A category planes, B category, and C category. And basically, the plane just gets larger as you go down the scale. I don't know if I mentioned it, but the airport's actually built for category A and B planes, class 2. They allow the class C's to land based on pilot discretion. So if the pilot feels like he can land the plane safely, there's no restrictions from that. It does make it a little bit difficult with class 3 airplane because the wingspan is larger. And there's some other ones that are privately owned that actually are kept in that airport. And then you'll see once in a while one will come in and land to do the customs. So they have a customs service at the airport. So sometimes a plane will just come in and land there just to do that. On the category results, we had 65, 71, and 75. But it was kind of interesting that it came out to be 80, 80, 80 on the averages for the A, B, and C. So really not confident with that. So that's where I suspect that on the sea level rate scaling, maybe my microphone on my phone isn't all that accurate. And then here's the results for the top 5 aircraft. So this is again going back to the A weighting, 18 measurements. So we threw out most of them. So 18 measurements for the top 5. And there was average of 76 dB. You can see here the E175 was the highest. That one came in at average at 78. And E145, so I had 8 of the E175. So I did have a bias towards the 175 because that's new. I really wanted to get a lot of readings from that. And then I compared it to these other ones. So E145, E135 are pretty close to the same. So we had 7 good measurements on that. So I think it's pretty close. So if you look at the comparison, 74 versus 78, so that's about a 40 dB difference between the two different planes. And then the next one was this CL35. Two measurements there came in at 73 average. And I got one of the PC12. This PC12 is a turboprop, and it runs at constant speed on the engine, even though it's not moving as fast as a jet. Speed is controlled by the prop, so they pitch the prop back and forth to control the speed. And that one came in at 76. It was quite high, in comparison to these other ones. It would have been right in between the 145 and the 175 if that had been the average. How noisy are the PEW aircraft? Well, when we compare it to other noises in the neighborhood, I looked at trash trucks, the mail truck, delivery trucks. Those were all, louder in some cases, 70 to 80 dBs. And one of the delivery trucks was 90 at one point. Actually, a trash truck when it was actually operating. The difference, though, is with the noise from the truck, it's probably measuring it about maybe 10 feet away, whereas with the plane, we're taking measurements that are hundreds of feet away. And so it's a hard comparison to make because the airplane's going over a longer period of time, and it covers a longer range, so there's actually a lot more people that are affected by that than by the noise from the truck or the other vehicles. And then also another thing that's been mentioned is garbage disposal. And the garbage disposal was 75 dB in my house. Another one that's mentioned often is Harley Davidsons are louder than airplanes. I guess that might be true because Harley Davidsons aren't allowed in our neighborhood. You can't drive a motorcycle here, so I get a kick when I hear about that one. The motorcycles are louder. And from what distance? So am I standing 3 feet away and I'm measuring the sound of a Harley Davidson motorcycle, or am I 100 feet away? What's the conclusion? Okay, so significantly more airplanes are flying over West San Marcos communities than in the past years. If you talk to any of the residents here that have been here for a long time, they'll all agree that what we're seeing now is an increase, a significant increase over the years. And I've even had people that have lived here for 25 years tell me that this is absolutely the worst they've ever seen. So there's something that's taken place. And I believe it has several factors that are not necessarily anything intentional. It just happens to be the technology for the navigation is improving. So a lot of planes want to fly RNAV approaches. Even a small aircraft that's on a visual approach may even use a handheld like an iPad or something with a program downloaded on that's running GPS. And they're not supposed to, but they may use it just to give them some idea of how low they are or how high they are to the ground. They're flying, making their landing approach. And then, of course, if you got the instruments in the plane, you want to use it. And that's some expensive stuff in some of these planes. So if you got a really high quality instrument landing system and you want to just rely on that, you take your airplane clear out to Escondido and then make the approach, which is anywhere from 12 to 20 miles farther into the valley than necessary. I think it's kind of one of those things that maybe they ought to look at it. And then the flight paths have changed. We can see that in the difference between the 2005 Part 150 noise study and the current ones, PEER, Program Environmental Impact Report. And then voluntary noise abatement procedures. They may be exasperating the negative impacts by directing the jets to fly the ILS. So that again means going out and starting out at the waypoint. So they might fly all the way out there and then come back. And it puts all the planes over our head though. And that's part of the issue that we're having is it's just too much traffic. The Category C aircraft are allowed, with exceptions. And then the 175 aircraft rank as the loudest among the top 5. Their average level is exceeding others by 4 dB. And I wonder if that doesn't have something to do with it landing on the shorter runway. Because I found a chart somewhere that said if the runway was under 6,500 feet, they needed to use a full flap configuration while they're landing. So I think at full flaps with landing gear down, we're probably getting a lot of noise just from the fuselage, and it's a little bit larger, and I'm sure the noise of the engine isn't really any different than any other jet that flies through, but for some reason it's louder. Checked against this on a monitoring system that's in San Diego. So for the San Diego airport, similar jets, it was actually an E-175. It was just a different carrier. I think it was Delta. It had the similar distance from the microphone, and that one was 3 dB lower. So I wonder if it has to do with that configuration. So something that I'm gonna look into a little bit more. Maybe we can get kind of an understanding of that, and if they're going to extend the runway and make it long enough to where these guys can land the plane properly, then maybe that's the solution. That could actually work out to be better. And then one of the big questions that we had, as far as our community is concerned, is what can we do about it? And I've been researching this for a solid 6 months. Pretty hard. I've read a lot of stuff. I've went through all the reports. I've looked at news articles. I've kind of compared what other places have been doing. And when they made the change with the flight patterns, a lot of airports had immediate impacts that were noticeable, whereas ours were kind of in the COVID era, and also we weren't necessarily at full capacity. We're still not full capacity, but they're starting to increase back to normal flight operations. But for all these other areas like San Diego, Burbank, LA, Orange County, there was another one too in there, I think Long Beach. All those areas, there were a lot of activists that the community activist people started up and started suing everyone. And one in Studio City that's really interesting. We have kind of a unique situation here because of the local control issue. So there's a lawsuit going on over that. And then if they do get local control over the airport, who's to say that they don't expand it anyways? Things change. That could happen as well. So some of the things that we can do as far as our community is concerned is we can stay vigilant on the impacts that we're experiencing here and try to record those and document as much as possible, collect samples of soot, so it's a big problem for everyone. And maybe at one point we'll be able to gather enough information that we can actually attend one of these meetings where they've been turning everybody down for stuff and have a sensible argument of why they need to do something to mitigate problems in our area. So I think that's something that's really important. So that's what we can do, is we can just continue to pursue a path of understanding. More knowledge, the better off we can be. So anyway, so that's it for the slideshow, and I hope you enjoyed it. If you stuck with me this long, I really appreciate it. If you want to give me some help with it, I don't make any money off of this. I'll never make money off of YouTube. I just do it for advertisement for my business is what I plan on doing. But I don't actually measure aircraft noise, so it's not something that I probably can turn into a service. Like I would kind of like to, maybe go out and help people do sound studies or something, but not having the engineering behind me, I don't think that it would be sensible to actually do it as a service. Especially if you're going to use it to represent something with the county or a city or something like that, where it's a public agency that has to review it, and that really needs to be done by qualified engineers. I kind of use it as a hobby right now. But if you did like it, you can hit the like button down below. And if you didn't like it, subscribe, stick around, and maybe you'll find something that you do like. By subscribing, I get some more viewers, and eventually I might click with someone that says, hey, I could use that. So again, I have a drafting business. I do plans basically for permits right now. I'm looking for other things to do. I kind of like to get into the robotics end of it and see what I can do with that as far as planning, or maybe even with the electric vehicle vertical takeoff airplanes. That would be kind of neat. Or I think they're called electric vertical takeoff and landing. That's what the acronym is. EVTOL. So those guys need charging systems. So maybe that's something we could work on. But yeah, for now, this is it. So thanks for coming. This is going to be RB signing off.